So this is joint work together with Leo Schmallenbach, who's also in the audience, a doctoral candidate at our chair, and Karin Heusel. And as Jens Peter very aptly introduced, so we're working on a topic that has in the recent past received controversial attention in connection to the role of female mentors in science. And we are very, very much devoted and committed to contributing to that debate in the most evidence-based fashion that we have in our, toolkit available. So with that, let me start by giving just a very short overview of what we can say we understand thus far when we look into the literature on this topic. So on the left-hand side, you see just one example of a paper headed by the statement "Mentors propel careers," and there are different outcomes that this line of research has looked at: number of publications, number of grants, mostly related to productivity measures, as here in this example of the snippet of the work by Marc and Uzi. There's also, as said, much other work. Interestingly, this line of research is mostly comparing juniors or protégés of mentors to those that work without a dedicated and visible mentor. And we are, less interested in that. The literature has documented very well how important mentorship is in science. But we are more interested in comparing juniors that are guided by mentors, and those mentors differ ideally, and we will see how convincingly we achieve this. Mentors that differ in terms of their gender, but not much on other observational characteristics. On the right-hand side, there is a quick tribute, if you will, to more recent literature. So starting 2016, then with contributions also in 18 and more recently, as Jens Peter mentioned. So gender likely matters in this relationship. We have here a study by Pizzoni, Jacques Meres, Paula Stefan, and Julia Lane, where they basically took graduate students from Caltech, so a very selected group of scholars, both in terms of the mentors as well as the protégés, and they looked at gender pairings in terms of their productivity. But there are also other outcome measures in this literature, like how long do people stick to the academic career path if they are mentored, and if that differs by gender. This more recent literature is a little bit mixed in terms of the effects that are found. In one paper that is also quoted here at the bottom by Call and Pierre Cantini, would find not much productivity differences here in terms of the gender of the mentor, but with respect to how long juniors stay in a scientific career, depending on the gender match. So there is evidence out there on this relationship, and generally speaking, there are a lot of compelling arguments that can be made why mentorship should affect the careers of young scientists. So in terms of these stylized pictures here, we are just alluding to a couple of arguments that are put forth in the literature. Obviously mentors have, a much better sense for how to navigate the scientific system in terms of what topics to choose, how to navigate peer review, but also when we think about more resource intensive fields like the life sciences, which will later also be our empirical setting, there is also a strong importance to having a senior partner, if you will, that just funds the research you're doing, because it's resource intensive. You need lab material, human capital, etc. Our work differs in a very simple way, if you will, from what I have shared with you on this slide. So we are less looking at, this diet here in terms of what they are producing. We are much more looking at this pair here in terms of, once there is scientific production, how is that production perceived by the scientific community? And that's the contribution we intend to make with this work, where we basically shift, if you will, from a strong, supply side focus to more of a demand side focus, but still we consider both of these sides in our work, but with a greater interest on the demand side. And why do we come, to this more demand side focused question here? So if we look into related evidence in the literature that's not per se related to a mentorship relationship, but rather to senior women in science, then we can make with a fair amount of confidence these two statements as the literature has grown in depth of evidence. So the first statement is that, the status of a senior scholar in science matters a lot. I have here two citations at the bottom, but we know, going back to Merton's work on the sociology of science, how important status is. And because juniors get attached to a senior collaborator, the status of the senior collaborator may serve as a surrogate measure for the scientific community when they evaluate the work that's been done by the junior, whether with the mentor or without the mentor, and we'll get to this distinction also in the course of this presentation. The second statement is that we also have compelling evidence that senior women get undervalued in science, despite the fact that they have a lot of accolades, a lot of other confirmations of their quality. Still, relative to male peers, they get undervalued. And if one thinks about the evidence on that statement, it ranges from when women get awarded prizes for their achievements, they often get less prize money for it if they win the prize in the first place, so to speak. Often they don't even win the prize in the first place for comparable work, but also they get less invitations to editorial boards, prestigious positions where they get visibility. Inducted into scientific societies comes later for many. So there's quite some evidence across the spectrum of scientific success metrics, if you will, where senior women continue to receive an evaluative discount. And so combining these two statements, we come to this question of, does mentor gender influence the evaluation of the work that their proteges produce? And that's the question we are very much trying to focus on with this piece of work. And in terms of what we are trying to dissect here a little is this difference that I alluded to earlier on supply versus demand. So we have on the supply side, we have in the literature on professional labor markets, we have, so not just focused on science, but general labor markets, we have this distinction quite prominent where you have one school that subscribes to the idea that women might, by means of their own choices, supply products to a market where the product is inferior. Now, the question is to what degree this is corroborated in the literature. The mechanisms that are offered, for example, is women might shy away from competition. That's work around the group of Gnisi, for example. It might also be that women select certain topics to work on in science. One recent example of such a claim or idea is that women might work on scientific topics that are particularly afflicting the health of women, for example. So women invent for women. And if that were true, then perhaps the audience that is receptive to the work is by construction smaller, because we have less women in science than men. So this would be more on the supply side explanation. On the demand side explanation, very briefly here, so we have this question of whether if we are able, by means of a research design, of a thoughtful, as we hope, research design, get to this question closer, whether protégés that are mentored either by a man or by a woman of highly similar quality, and the juniors being of similar quality. So in the very quick idea, all else equal, do they get an evaluative discount that can be attributed empirically to gendered effects? So this is the baseline hypothesis that we have here at the bottom, that we came to when we looked through literature. So women relative to men mentors negatively, and here's this this bracket, less positively impact the evaluation of protégés' work. So the thought here really is that we are not, questioning, coming from the literature, we're not questioning whether mentorship might be, less important or less productive for protégés, as the literature has suggested. That's not the idea. The idea is, mentorship is important, and mentorship will likely positively impact the careers of juniors. However, is there a difference that women mentors might propel, less pronouncedly their protégés as men? But we obviously cannot just stop at this baseline, so we need to figure out, what could be attributed if we find effects to supply versus demand side. Now, research design, and I want to spend a minute here, particularly in connection to what also Jens Peter mentioned in the introduction, and several of you might be familiar, is the work of Al-Shabli and colleagues in Nature Communications that, after controversy got retracted. Now, the importance here is we started this project from thinking about, even before the Al-Shabli paper came out, we started this project by thinking about what would be an ideal design for getting at this question. And so the first point here is, randomly assign juniors to mentors. Why that? Well, because you would, not want that juniors of certain quality match to mentors of different gender, because then we might mistakenly attribute, an evaluative discount to the mentor, which is in fact more a quality criteria of the juniors. The second thing one would ideally have is randomly assign gender to mentors, and obviously that's not feasible. So the next best that we can come up with is to take, in replacement of the first randomization, take a highly prestigious fellowship of the US National Institutes of Health. So very brief sort of situating fact here, the NIH is the largest funder of science globally, an annual budget of roughly 30 billion. And as part of their budget and as part of their charter, they are developing the next generation of scientists by means in particular of this research award here that is bestowed on nationally competitive scientists. So by construction, this design should leave us with grantees of this program that are internationally competitive and basically a strongly positively selected cohort that don't really differ in terms of their quality. And since there's not much of a quality difference, borrowing a queuing imagery from the Podolny paper that's cited here, we're picturing mentors that basically get contacted by different juniors, and I can talk a little bit more about how this if you will, matching process works from interviews that we have conducted here with F32 recipients. But it's essential that mentors basically look at these juniors and can't really fully decide, which one to pick, because they're all of a very strong quality. And so the second one here is assign gender to mentor. So what we ideally would want is, we would want here, this is a picture of two PIs in Boston, and they both are highly esteemed members of the scientific community. NAS members, whatever metric you pick. But those two here are actually running the same lab, and they are a married couple. So the idea here is to basically have identical mentors in terms of observational quality, and just basically switch to gender. So this here is in a nutshell this design. So we basically take the recipients, then as part of this program, which is a distinguishing factor, we believe, of our work, there is a dedicated mentorship. So the NIH requires that mentors basically stick up for the grantees for a period of up to 3 years, and work with them and shepherd them into the transition to faculty. And we look at the output of this group of scholars. So it's roughly in the end about 4,000 juniors. So we look at 60,000 publications in total. In the course of the empirical work, we lose some publications in terms of the matching that we do. But we look at basically these journals, these journal articles, and at forward citations as sort of the institutionalized metric for how a scientific community evaluates work. And so just a quick rundown of descriptives before we go into the results. So here you see that in terms of, this is just one metric on the juniors. So on the F32 recipients with a female mentor, that's the black line, and the gray line is with a male mentor. And you see that before matching, we do not see any distinguishable difference in terms of number of papers, but can also be other characteristics that we matched on. So very homogeneous sample. In terms of the mentors, the picture looks a little different. So here you see the black line here again being the female mentor, the gray line being the male mentor, and left is before matching and after matching. And so the matching that we do, we use coarse and exact matching, and match the mentors on several characteristics that are also relevant for the NIH when they evaluate the grants. So it's number of papers, it's the impact of the papers in terms of the journal quality where it's published, it's the experience of the mentors, the grant funding, their prior grant funding, etc. So several variables we match on. This is just an example of the number of papers and how they differ. So women have tangible fewer papers than men, even in the selected group of scholars. And after matching, we are able basically to make the mentors observationally equivalent, except for their gender. Now, model specification. So we basically look, as mentioned earlier, we look at citations as our dependent variable to a focal publication, and we regress this on a dummy for the female mentor and on a vector of control variables. So it's, several here are mentioned. So again, the mentor characteristics, the F32 recipient characteristics in terms of their publishing track record, experience, etc. But also the characteristics of the focal publication. So how many co-authors, composition of the byline, except for the mentor and junior, GIF, etc. So expected citations here as last variable. I want to just spend 1 more minute on this, because we believe that this here is actually an asset that this work has created or resulted in. So when we think about a focal paper, we try to come up with a metric that allows us to glean how much citations one would expect the focal article to receive given the article content. And the article content in the life sciences is basically ascribed externally by trained librarians of the National Library of Medicine, so-called mesh terms. So it's keywords, if you will, that get assigned to articles, but externally, not by the authors themselves. And so we use here as an example here on the left. So you have one publication out of our set. So in these keywords that I alluded to are mesh terms, medical subject headers. And so here you see the mesh terms of this focal article. And we basically take these mesh terms and take all publications in PubMed that were published in the same year, look at what their citation count is in a 10-year forward window. We can also vary this window, but then we basically discount these future citations that are received to the day the article is published, and that gives us a measure for expected citations of the focal article that we are having in our regression set. So with this foundation being laid, I can go through the results with starting descriptive evidence of when we look at the papers that these protégés publish over a 10-year period, and we look at what their average citation count per paper is. So we see that F32 recipients with a male mentor here on the left, this is the actual average number of forward citations across these papers, is about 10% higher than of the female mentored protégés. And this is just descriptive without doing anything to the data. Then we run the regression, a negative binomial. I think I haven't said that explicitly earlier, but negative binomial to account for the skewed distribution of the variable. So here you basically see the descriptive statistic just reproduced in the regression. So it's roughly a 10% discount. So you want to think about these here as incidence rates in the regression. So 0.9 translates to a 10% citation discount. Now, when we add all of these control variables that I described earlier, which essentially capture much or most, if not all the supply side factors we came across in the literature. So thinking of this as a supply side regression where you control for what's the mentor's ability, what's the junior's ability, what's the research characteristic, what journal published, what type of content with the expected citations it's to be received. So accounting for all of this, we roughly take away half of this discount, roughly. But now the interesting question that we sort of had, particularly when we entered the expected citation metric here at the bottom, we were wondering, well, if, for example, these quite prominent explanations in the literature of women might select into certain topics that might be less attractive to a broader audience, and hence they might receive an evaluative discount. Since this is not materializing, we were wondering, okay, so at what's the locus of the distribution of expected impact where this discount actually occurs? And so when one looks at this, so this graph basically takes the papers that you had seen earlier, so the 45,000 papers, and cuts them into percentiles of expected citations. And so here we basically picture quartiles, but we have done all sorts of splits. But this is informative here, this quartile split, in the sense that you want to think about this area here is sort of the research content that's expected to draw fewer citations, if you will. Here is the higher end. So what you see that when you look at the x-axis relative to the role of the mentor's gender, so this is the female dummy plotted here. So you see that the effect really is on those papers where the protégé is producing work that would be poised to attract citations. So it's in that area of the distribution where you have the most impactful work. So really the right-hand tail effect on citations, if you will. But what's important here, bearing in mind what our sample composition looks like, it's a highly selected group of people. So we have about 85% of their productivity in this right-hand tail. So this NIH supported, group of elite juniors with dedicated mentors produces, much of its work in this right-hand tail. So basically, there's a discount for the majority of the work and arguably the most important work. So now switching to the demand side and the question of, so who does not cite? Like, what's the reason why we have, particularly for work that's really, poised to be highly cited, where the scientific community builds on. So who's not citing? And in order to answer that question or get closer to an answer, what's important is to understand, so who's at risk of citing, right? I cannot just say, look, I basically count the ones who cite and then have a conditional metric on people, citing. What's important is who's at risk of citing. And so we again take these mesh terms that I introduced earlier and basically look at, what's the gender distribution of the entire scholar community as recorded in PubMed. What's their gender composition of people that work on mesh terms that are, that are the same mesh terms as the focal Protégés paper has. And so here you see that there is basically no variance between male mentored F32 recipients and female mentored F32 recipients in terms of the gender composition of the audience they cater to. So they are catering, if you will, to 36% being women, and obviously the flip side being men. And the same goes for last authors of, for forward articles that are working on the same mesh terms. So here we basically considered all articles that get published 5 years after the focal protégé publication and to get this gender distribution. But we also did 10 years and there's almost no variance. So what does that tell us? It tells us that the risk set is gender invariant. So, female mentored protégés are not working on different topics than male mentored protégés with respect to the gender audience they are catering to. And so when we, control for the risk set and basically then split our dependent variable of citations, which was just a count, into now a dependent variable that is cognizant of the gender of the forward citer. So basically can look at, what are the citing papers, who are the first authors, who are the last authors on these forward citations, genderize them, and take a look at, against this risk set of citers, who undercites. And so one sees that in terms of first authors here on those forward papers, male first authors tend to undercite female mentored work about 10%. There's no such effect for female first authors. For last authors, we see sort of this flipped picture. So we have also, I'm sorry, one's back. So we have also for last authors, a discount like for first authors. So male last authors undercite female mentored work. There is a benefit on the other hand here that's measurable for female last authors oversighting, if you will, female mentored work. But given that the cell is a lot smaller, there are much fewer senior women in the scientific community still. So this oversighting in absolute numbers does not compensate for the underciting of men. So it's a gendered citation pattern, but given a risk set. We also considered two last explanations here with which I want to close. So we also asked the question, might that be because we have evidence in the literature that these blue bars here result from from self-citations? So are men perhaps self-citing more than women? And we do not find evidence for that. So basically, the citation discount that we see is for female mentored work is very, very similar if we exclude self-citations. So this is perhaps more or could be a dynamic in this particular field of science, so in the life sciences, because there has been also conflicting evidence on self-citations in the literature, where, across scientific disciplines, there is evidence that men might self-cite more. In the life sciences, there is evidence that that might not be the case. And here in our set of papers, we do not see that would have any material effect. The last question that we asked ourselves is, so do these fewer sites come from people that are familiar with the work, or ought to be more familiar with the work, in terms of, are they working in same fields or highly related fields, or are they really from distant fields? And one can see that the discount really stems from same field scholars. So people that are likely familiar with the lab, likely familiar with the PI, but even if that might not be the case, still this would suggest that it's not lack of awareness as an explanation for the discount, which could have been conceivable in this field here. It seems to be basically men working on topics that are close to the focal article that seem to drive an undercitation of female mentored work. And this is also the conclusion that we are currently drawing. So to summarize, we find that there's a 10%, just descriptively, 10% fewer citations of female versus male mentored work in terms of attracting citations in this window of 10 years. Half of the citation discount roughly can be attributed to supply side factors. Although allow me one word of caution here, because it's a little difficult if we, just because of sort of constraints in the data that we all have access to. So for example, if we include in the regression previous funding of women, and that might explain part of the variance on fewer citations, that in and of itself might have also to do with demand side factors if women would have systematically lesser access to funding, for example. So, but to be conservative, half of this effect could be attributed to supply side factors. So the remainder is on the demand side, and particularly afflicting the most promising work of these young scholars. And it seems not to be driven by content choices, but rather by male authors close to the research content underciting. And in all, this finding arguably goes beyond individual career considerations of the protégés, because it also has ramifications for how the scientific community builds cumulative knowledge, what gets cited, what gets built upon. And so with that, I would like to close my part of the presentation. I'm very much looking forward to the Q&A, as it's always difficult to cover everything in half an hour. But nonetheless, thank you very much for your attention, and very much looking forward to engaging with you.